I'm Steve Plum, Senior Editor of Manufacturing Engineering Magazine. Welcome to another edition of SME Media Webinar. Our topic today is Workholding Products and Digital Tools for Process Improvement. This presentation is sponsored by Carr Manufacturing, which provides high-quality tooling components and industrial parts to a wide range of companies and industries worldwide. Our presenters are Carr President Colin Frost and Engineering Manager Josh Hirschbach. They both have a wealth of experience. Colin has been with Carr for more than 16 years, while Josh started with the company in 2014. Before I turn things over to them, I'd like to outline how the webinar will proceed. On the right side of the screen, you'll see a question and answers box. If at any time during the presentation you'd like to ask a question, please type it in this box and send it along. These questions will be answered at the end of the presentation. Should you experience any difficulty during the webinar, such as a blank screen or lack of sound, please use the Q&A box to alert us, and we will respond individually in writing with a suggested fix. That brings us to the final housekeeping item. I'd like to remind you that the presentation will be available to view later today. You may then watch the recorded version of this webinar at any time and place when you have more bandwidth. You may also watch the webinar as many times as you wish to catch details you might have missed or for any other reason. All you need to do is to sign in again using the credentials you used to join us just now. You may even share those credentials with colleagues who might benefit from learning more about this topic. Now let me turn the microphone over to Colin and Josh.
Thank you. Go ahead and get started. All right, we already had our introductions, so Colin, I'll leave it here with you.
Certainly. Thanks for joining us, everyone, today. Carr was founded in 1952 by Earl Walker, and it's been continuously family-owned and operated since. Earl's daughter, Nance Frost, is the owner and CEO today. We have two primary manufacturing facilities in the United States, our main headquarters in St. Louis, Missouri, and our second plant, which is located in the Austin, Texas area. In 2019, we opened a branch of our business in India to be able to ensure that we can serve our customers and our customers' supply chain needs efficiently throughout Asia. So that's a little bit of history there. So let's jump into the good stuff. In terms of the agenda, we're going to talk a little bit about process improvement. I'm confident you all are experts, and we're not going to dwell too much on this. We're going to then talk about some new products in workholding. Then Josh is going to talk to you about some new digital tools, and then I'll hop back in for future trends, and certainly we'll answer any Q&A that you have at the conclusion. So so what is process improvement? Process improvement is identifying, evaluating, and enhancing an organization's business processes to improve efficiency and quality standards. So why do we do this, right? Ultimately, we do this to reduce waste and improve quality, both of which result in increased profits. Process improvement within the course of this webinar will be focused on not only workpiece and productivity, workpiece in terms of workpiece quality, workpiece productivity in terms of manufacturing, but we'll also be talking about it when we come to the digital tools. We'll be talking a little bit about process improvement for those of you who are doing work in designing tooling, workholding, and fixturing to allow you to improve your processes in the design stage of those projects. So the first topic we want to touch on here a little bit is automated workpiece loading and inspection. So automated workpiece loading and inspection is going to be a key portion anytime we're talking about improving our manufacturing process through automation. And it comes in a couple of different flavors. So the first thing that we can do to really make an improvement in terms of supporting automation in workpiece loading, and that's to provide position sensing of the workpiece. As we all know, robots are really, really dumb, and they pick up the part and they put the part in the same place every time, or at least they try to. It doesn't ensure that the workpiece is picked up properly, oriented properly, or even loaded properly within the tool. Providing part position sensing is one way that we can do this. And these products come in two styles. The first style is a non-contact air sensor. And the non-contact air sensor is designed to be used with an air gap measurement sensor. So the non-contact air sensors are controlled very tightly in terms of their overall height, because that is a critical point from the end of the sensor to the workpiece is what is actually measured using the air gap measurement sensor. We also have available a contact style. The contact style is certainly different because it can be one of the qualified points within the tool. So it can work as a rest button and also a position sensor. So the big advantage of the contact style is that, first of all, it's a qualified point, right? So you don't have to add an additional feature to your tool to be able to ensure that your workpiece is loaded properly. Secondarily, the non-contact sensors can be fouled or troubled or fooled sometimes by coolant, swarf, and any other contaminants or debris that you may have in the manufacturing area. But really the biggest benefit of the non-contact sensor is the fact that you can potentially use the non-contact sensor to do workpiece measurement. Now, of course, this is only really in one axis, right? Because you don't really know where the top of the workpiece is. But you can certainly measure the distance from the top of the non-contact sensor to the closest surface of the workpiece that you're sensing against. Additionally, there are some interesting new developments and opportunity for automation within inspection using laser inspection tools. The picture that we see here on the right is actually half of the fuselage of the new Boom supersonic demonstrator airplane that will certainly fly if it ever finds an engine. but laser inspection provides superior accuracy and speed, especially for larger workpieces. They have become popular to replace the use of a portable CMM. And even in a production environment, they can provide automated inspection. Excuse me. To provide automated inspection, you need to have an inspection tool, and that inspection tool needs to include a laser target nest. The laser target nest is designed to hold a spherical target ball, and they can either be installed on a temporary basis using taper adhesive, like we can see here in this image on these wood supports. These are all laser target nest, and Boom here was measuring the distance between a feature on the fuselage and the laser target. Also for permanent installation within automated inspection tools and fixtures, there are also versions available that use screws and locating pins for a very highly precise location of that target nest. So these are two opportunities for process improvement within what otherwise might already be automated opportunities or automation within your facility. Additionally, there's recently been some new developments in the improvement of speed and accuracy of automotive checking fixtures. You might be wondering, what is that checking fixture? A checking fixture is used to inspect plastic panels and assemblies during the manufacture of those panels or assembly of a vehicle. If you think about our modern cars today, virtually everything is a plastic item, and we have already leaned out the manufacturing process right through process improvement, primarily by eliminating threaded fasteners. All of those threaded fasteners, or I should say most of those threaded fasteners, have been replaced by clips. These are the things that bedevil us anytime we bump our car into something and then the bumper is hanging off. We have to go get those little clips. So inspecting plastic parts, whether they're radio bezels or mirror housings or front bumper fascias like we see in this image here below for this Mercedes-Benz C-Class. They're difficult and pose complicated work holding challenges because all of these plastic materials are relatively lightweight, which certainly we love for fuel economy. But as soon as we begin to try to clamp onto them and to hold them into place, this begins to distort the plastic panels. So this makes that inspection and that work holding and those tools a real challenge. So there is a relatively new patented product called the Clip Buddy. This relatively straightforward item is actually very precise, and it's designed to hold on to the workpiece using the same method as the workpiece is retained in the vehicle. So the most obvious advantage of this becomes that because we're holding on to the workpiece in the same way that the vehicle will hold on to the workpiece, we're not providing any distortion to the plastic part or assembly. This then, of course, allows the part to be inspected accurately and to eliminate or eliminate as much as possible operator variability and inputs upon that inspection process. Additionally, this product supports remote operation and automation, which is something that we're beginning to see as more customers are able to incorporate white light inspection within their check fixtures. So here we just have a couple of additional examples of how exactly this works. On the right-hand side, we see the front of some kind of cover or fascia, and we can see transparently through that the item in that bluish purple is the Clip Buddy holding on to the clip. And then on the left-hand side, we see how these items are used in simply another checking fixture from the back side. You see the items there are designed with the red handles. All right, Josh, you want to take a few minutes to talk about new digital work holding tools?
Absolutely. Thank you for the great information, Colin. Now that we've discussed a few different ways to support process improvement, let's go ahead and dive into and talk about some new digital work holding tools to support this. So let's first review a few examples on how digital tools can improve process. Digital tools can help support process improvement, providing automation of repetitive manual tasks and processes. They can reduce the chance of user error when calculating values. Digital tools can also provide a user with a unique set of tools to further support process improvement by overall simplifying the task. So one example of a digital tool used to support process improvement is our configurators. Configurators allow users to configure standard parts or specify custom parts dynamically. This tool can also provide pricing as well as CAD models on demand. So let's go ahead and bounce to the website, and I'll give a live demo of one of these configurators. So let me share my screen here. All right, so we'll go to the website. In order to get to a configurator, there's two ways to get to these. You can either go to the product catalog and navigate to the specific item you're looking for, or we can hover over product catalog or engineering resources and scroll down to CAD configurator. Once we're on this page, it'll take you to all of the available configurators on carlane.com. These range from quick change bushing handles, press fit bushings, ball lock pins, cable assemblies, clamping pins, just to name a few. However, we'll be demonstrating one of our more popular configurators, and that would be the bushing configurator. So I'll go ahead and click on that now. Whenever we click on this, we want to ensure that we are logged in with a carlane.com account. This will allow us to generate CAD files and pricing on demand. But the first question we'll see here is configured part quantity. So we'll want to enter a quantity. I'm going to go with 10. This is important in order to get an accurate price, as our system takes into factor setup time and manufacturing processes. So after we enter a quantity, we will click Next. This will then navigate to the configurator page. Okay, now once the page is loaded, we'll see a description at the top explaining what the configurator is, an example part number, style bushing, and then we see a question. And the first question we have here is, do you require a special OD, yes or no? For this demonstration, I'm just going to leave it at no, and I'm going to select a 3/4 of an inch OD. Now, the next question is to select a standard drill size. So I'm thinking 1/2 an inch would be a good drill size. So I'm going to scroll down to 1/2 an inch. And then we can also see there's a question where we can modify this ID. So we can select a special ID anywhere between 0.3125 to 0.5312. However, I'm good with 1/2 an inch. So then we'll go to the next question asking if we would like a special length, yes or no. Once again, I'll just leave it standard and we'll select an inch. And then finally, we're asked if we want a reamer ID tolerance or not. So sure, we'll select a yes. Now after that is done, we will be able to see the quantity we specified in the top right, as well as our configured part number. However, we do have the option now to generate a CAD file. So I'm going to go ahead and click step file, as that's the format I would like it in. And then once we select our CAD format we want, we can click finish. Once we click finish, this will send it off to the configurator. We then click download CAD file, and then this will generate the request to send the CAD file to your email. And we can also click close tab and add to order. And this will add to our pricing and availability, so we can see the unit price as well as the line item total. After this is done, if you do not want to wait for the email, we can also navigate to My Dashboard. Once we're on My Dashboard, we can also see the CAD files we have generated, and we can download them here. And it also has an expiration date for this CAD file. Now we'll go ahead and jump back to the presentation. And we'll talk about another digital tool we offer, includes calculators. Calculators can support process improvement by providing the user with a tool to automatically generate values such as clamping force and hoist ring load information. These calculators don't only save time, but also can help reduce the chance the user performs an incorrect calculation, resulting in an error or some sort of failure. Two of our most popular calculators include hoist ring calculator, as well as the clamping force calculator. So once again, let's go ahead and jump into the website for a live demonstration of these tools. All right, I will navigate to the product homepage. So once again, there's two ways to navigate to these tools. We'll go through the product navigation first. So we'll click on hoist rings. After we click on hoist rings, we can click on technical information and hoist ring technical information. This will take us to the page this calculator is located on. However, we can also navigate to this page by selecting Engineering Resources, Technical Information, and then Calculator Resources, and then all the available calculators on carlane.com will be located here. So I'll go ahead and click on Hoist Ring Technical Information. And at the top, we can see some descriptions of this calculation as well as the actual formulas to calculate these values. However, if we scroll down to the bottom of the page, we can see the actual calculator, and it gives us a few selections here. So we can select the units in pounds or kilograms. I'm going to leave it in pounds. We can type in our object's weight, in which I'm going to type in 20,000 pounds. And the number of hoist rings we are using to lift this item, I will leave at the default value of 4. Now we can also select the lifting angle. The default value is 70 degrees. And we can see that this results in approximately 5,320 pounds per hoist ring. However, as this is a dynamic tool, we can also reduce this angle. And if we were to make the angle closer to 10 degrees, you can notice that a few thousand pound load is now 28,000 pounds per hoist ring, dramatically increasing the overall force on each of these items. So now we'll go ahead and discuss the other calculator. We'll go back to Engineering Resources again. Technical Information. Once we're on Technical Information, once again, we'll click on Calculator Resources, followed by Clamping Force of Standard Clamp Straps. Now, once we're on this page again, we see an example of predetermined values of different stud sizes for clamp straps, ranging from a 1032 all the way up to an 1'8" bolt, their recommended torques and their clamping force that result with these values. However, in the case that you need to use custom values, you can scroll down on this page. And once again, start by selecting your units, inch or millimeters. I'm going to leave it in inch. I'm going to change the stud major diameter to 3/4 of an inch. I'm going to change the torque value to 20 foot-pounds. I will leave the coefficient of friction alone at 0.2, which is a good coefficient of friction for a clean, dry stud. And then the lever ratio, I will leave at a 2-to-1. This is typically used whenever you're calculating forces for clamp straps. And then after we enter this information, we can notice the tensile force in the stud, or the axial force, results in approximately 1,600 pounds. And then the clamping force results in 800 pounds. And then if we were to change these values again, these will automatically update based off your inputted information. Okay, go ahead and bounce back to the website. All right, now that we're done discussing a few digital tools, I'm going to pass the presentation back to Colin to discuss future trends in work holding products and digital tools.
Thanks, everyone. I imagine that for most of you, you are generally aware of the types of capabilities that we've discussed today, whether it's within the products or within digital tools. I hope that taking a look at some of the specific examples that we discussed there helps to crystallize and clarify how such things might be deployed within your organization. Then I'd like to just take a few moments just to talk a little bit about certainly where we see from the Carr Lane manufacturing point of view work holding products and digital tools headed over the coming years. Within work holding, we see a couple of trends. The first one is customers are looking for ways to automate existing work holding. So this seems fairly basic, right? Customer says, I have a tool or I have tools, and I'd like to be able to make them compatible to work with robot loading and unloading. I'd like to make them more automation friendly. I'd like to incorporate part position sensing, things like this. How do I do that without having to design and build an entirely new tool. So we're certainly seeing some interesting opportunities to try to help to support that, allowing customers to automate for the best possible cost. So I hope to be able to have some more things to talk about with customers on that in the future. We also see for customers who have been working in automation for a while now, the desire for that work holding to provide additional benefits. The most interesting one of these has to do with position monitoring and clamping force monitoring within hydraulic work holding to be able to provide part measurement during the clamping cycle, which can help to identify non-conforming product prior to the processing of the product. If this is something that you're interested in learning more about, certainly feel free to get in touch with us. Otherwise, I expect that we'll see more of this going on in the future, and it'll become less sophisticated. It's fairly sophisticated today. It takes quite a significant investment in terms of teaching the system what's conforming and what's not. But I think we'll see that continue to get simpler, faster, easier, and better. And then lastly, work holding that is simple for companies to, quote unquote, self-integrate. So for our customers who are smaller and medium-sized machine shops, right, who are not Fortune 1000 businesses, I think we continue to see the desire for those shops to say, how can I do this integration work myself? And how can we do this to help control the cost and build expertise within our own organization? And that means, how do we design work holding products that easily live within robot and automation friendly ecosystems, right? How do we get our work holding to easily talk to our machine tool, right? We were just talking about work holding providing part nonconformity detection through measurement, right, as being complex, right? How do we make that easy? How do we make the integration of that easier so that customers can do that? So these are essentially three branches from the same tree, right? The idea is, how do we use what we've got, and how do we make our work holding that we have more productive, right, within the automation setting, and then how do we make it so that it can be easily automated without needing a whole lot of outside assistance. And then in digital tools, we certainly see a further expansion of configured options and items. And really the advantage of that expansion becomes that it helps to present you, the designers and engineers, with a better understanding of what is possible, and ideally allow you to select something that is a modification of a standard, as opposed to having to invent or create something that would be a complete one-off special. Additionally, for those of you who are familiar with our product catalog, you know it involves thousands and thousands and thousands of items. This makes it challenging sometimes as a designer to find what you're looking for. This makes it challenging sometimes to be able to keep track of what's been used in tools, what's in process, and then also difficult for people like your procurement team to figure out what to buy, when they need to buy it, and then keep track of the item once it's in-house. We do see the potential for integration using APIs to be able to automate data sending and receiving between ERP systems. Right? I think exactly how this could work and how this could be a significant benefit. I think we all think it can be a benefit. I think there's certainly a question about how one integrates it all. But APIs are getting easier to use and more common, and I think we'll certainly see, we're just a few years away probably from publishing an API, potentially of our own. As part of the expansion of configured and configurator capabilities becomes automation of the to order cycle. So what do I mean by that? As Josh showed you, you can go through the process of getting a price for that item. As configuration tools become more sophisticated, that allows the configurator itself to provide more price and delivery information, which can give you, the designer, price and delivery information at the time of design, which also means, given all of everybody's short time schedules today, that it may make a lot of sense potentially to just simply place the order at the time of design, ensuring that the product will be available to you for use in your solution at the time that you need it. And then I hope that what you all saw in Josh's section of the presentation about digital tools was a set of sophisticated tools that appear to be easy to use in interface from a user experience point of view. And that'll be the other big improvement that we continue to see in digital tools, is that user experience ideally will become better. I have been at Carr Lane long enough to remember the old price and availability configurator, which really, to use, you had to download a 7-page document, go to the appropriate section of the document to learn the secret code that you needed to enter in order to be able to configure an item in a certain way. And certainly it didn't deliver you anything so special as a customized CAD file. So it seems like a minor thing. Hey, the user experience is fine. What does it need to get better? Well, it certainly needs to get better to be able to match the level of sophistication that's available within the tool itself. All right, Josh, you have anything to add to that?
No further comments here. We can go ahead and move forward to the questions and answers.
Great. Well, thanks, Josh and Colin. A lot of good information there. As you mentioned, we do have some questions already that have come in, and it's not too late to ask them if you have one outstanding. And remember, if you're unable to stay on till the end, that you can revisit this webinar anytime you wish. So to start with, you talked about some of the benefits of automation, but on the flip side, can automation be detrimental to the process or improvement process? And if so, how can you avoid such pitfalls?
Well, I think if we think about process improvement, really in its end state, right? How do we improve the profitability of the products that we're manufacturing, right? How do we improve customer satisfaction while at least maintaining the profitability that we have, right? So essentially, how do we improve product quality without costing more money? I think then there's a legitimate question about whether automation is always the solution. And certainly automation is a big term, right? It encompasses a lot of things, right? But I think what we certainly do see is we see some customers who seem to jump into automation because it's what everyone is talking about and what everyone is doing. And unfortunately, they jump into that automation without fully understanding their process and process variability. And then they carry forward those process challenges that they have. And those process challenges then just become exacerbated by automation because there is no human intervention. There is no part-to-part human intervention adjustment of machine tools, of part position, of work holding, all these little things that human beings do minutely all day, every day. And so unfortunately, sometimes the automation becomes more detrimental than it is beneficial because they haven't necessarily identified what the pitfalls are within the current operations.
Okay. Another one that relates to automation if work holding devices are positioned as datums, how can they perform measurement?
Right. This is a good point. Right? So, certainly, if you would need to be able to position your work holding device in an area that is the area that you want to measure. So the application that we're speaking about here was an application in which a customer was clamping onto a very large die casting. And that die casting didn't receive any inspection prior to being loaded into the machine tool. And then based upon features that they were able to determine whether or not the part was conforming based upon whatever those features were that the clamps were clamping on prior to performing the machining of the workpiece. I agree, it's a real challenge, this idea that we use work holding to solve this problem exclusively. However, there are certainly a number of additional potential opportunities for process improvement while allowing work holding to do increasingly sophisticated things. One of those, if we imagine, if we have a machining center and we're doing heavy machine removal, certainly we can detect chatter and vibration in the spindle, but spindles tend to be very rigid and may not detect a lot of chatter and vibration. We also know that chatter and vibration is very frequently caused by a work holding challenge. So we could, for example, put a vibration sensor within the clamping arm of a hydraulic clamp and allow that to detect a certain amount of vibration in the machining of the workpiece. So I think at this point in time, we're just really getting into this, and the sky is kind of the limit here, right? Other things that we've thought about and kicked around is temperature sensing, right? If you have a lot of heavy machining to perform on a workpiece, if there is too much heat building up in the workpiece, can we use temperature sensors, right? Contact force sensors, right? We all know theoretically how much force a clamp should be exerting onto a workpiece, but do we want to provide actual real-world values for that? Is there value to that? Is there value in the application? It is all, I think, really to your point, highly application sensitive.
All right. So in real estate, there's an old adage, location, location, location. I guess the same could be said about work holding, position, position, position. Can you elaborate a little bit more about how part position sensing can enhance process improvement?
Sure. So I think if we think about a human loading a workpiece into a tool, we may have work instructions for that tool, right? We may say that you need to load the workpiece in a certain fashion, right? You need to make contact first with this physical locating point, and then secondly, this physical locating point. Or you may need to tighten clamps or work holding in a certain sequence, and we can automate that, right? We certainly can automate that. We can tell the robot to load things in a certain way. We can have sequential clamping valves and clamp things sequentially. I think the question becomes, do we perform a double check? I think for most of us in automation land, the answer is no. We say, well, thus far, our scrap rate has been an acceptable level. And so we know that we have some misloads, but those misloads don't cause damage and they don't cause us issues. But I would say that one of the things that they cause in our facility is they cause machine downtime. Right? So misloads may not cost us a lot of money until the work center stops working. And if the work center is running unattended and no one is in the facility, right, then we may miss out on several hours of production. If we have an employee who's running multiple work centers, we may miss out on minutes of production. it's this opportunity cost that makes us think about the role of some sort of verification, right? Hey, is the part loaded correctly? Is the part loaded in the way that we think it should be loaded? And then additionally, is there a problem with the workpiece, right? If we're talking about castings and we're talking about we have a qualified point that we need to make contact with, if that point has a little additional area of sand, or if it was over ground, if it's on a parting line, for example, right, to ensure that the workpiece is where we think it should be before we begin doing that work. Because if it isn't, then it may be as simple as having automation remove that workpiece and set it off to the side and continue working without pausing within the cycle.
All right. So for decades, the go-to for continuous improvement, process improvement has been applying lean principles. Does the Carr Lane system use lean principles? And if so, how do you incorporate that into workholding?
I think within the design of workholding tools, and when we think about lean, we really think a little bit about what I just touched on, right? We think about ideas like poka-yoke, right? We think about how do we error-proof the error-proof system. Certainly a lot of what we do in workholding is to try to make up for how dumb robots are, right? When strangers who don't know anything about our business ask me what we do, I say, we make parts that help you ensure that your workpiece is where the robot thinks it is, and that when you're doing work on that workpiece, that it's not moving around within that process. And I think that is the primary lean principle, right? We're going to invest time, effort, and energy in the automation of a process. What do we do to make that process as bulletproof as we possibly can? And I still think that we're still at the very cusp of that, right? We're still relatively early in that. And I say that because we're still exploring these additional opportunities that might be possible within workholding, like part measurement opportunities, right? And then other potential attributes, physical attributes of the workpiece, right? Vibration, temperature, what have you, that we might be able to detect that potentially can be the root cause of nonconformities in the future.
So we have a few questions related to the digital tools. First off, how often do you use your own digital tools and your daily processes, the configurators and your calculators?
Well, I would say that's dependent on what a customer is really looking for. For example, if they're looking for a CAD model, since I have the master files located in our facilities, typically I'll open that up. However, if it's a quick configuration, I find myself using these tools quite often. And then in regards to calculators, we make this so that way we don't have to do those calculations manually. So I quite extensively use some of the clamping force calculations and then the hoist ring calculations whenever I'm assisting customers on a conversation, a phone call, an email, whatever it is.
So what creates the limitations for configured options?
So
I can speak to that a little bit. I can speak to that a little bit, Josh. And this is a vagary of what configurators do. I touched upon a little bit the future opportunities when it comes to the configure to order cycle and what that can mean for a procurement of products to ensure that your tool makes its way out to the customer in a timely fashion. The configurators today that we run at CLM provide a lot of back-end automation. We actually build the bill of materials and the job routing within that configuration, so that if you choose to purchase that item, that manufacturing job, that manufacturing order flows automatically to the planning team and onto the shop floor with no human intervention. So because of that, we tend to be fairly conservative in what the maximum allowable configuration might be. So for example, in drill bushings, we sometimes have customers who want a very thin wall drill bushing. How thin the thin wall of the drill bushing can be is a complex calculation based upon length and wall thickness, as it is a ratio of diameter. This is typically guided by the physical people who can perform the work, more so than a series of theoretical calculations. So because of that, we sort of back away from those and into the world of things we feel good about, right? Sort of the known knowns, if you will, right? Hey, we know we can make these thin wall bushings. So therefore, we can automate the pricing and the manufacturing order, job order creation information effectively. We know we can make this so it can flow out to the shop floor without any human intervention. Other items, yes, we may be capable of manufacturing them or providing them, but we need a human being to take a look at it to ensure, yes, this is something we can do, or yes, this makes sense for the customer, or yes, we can produce this for a reasonable cost.
And in terms of the calculators, I know they've been on your site for years. What types of customers are using them today, and who should be using them, and why aren't more people using them if that is an issue?
Josh, I don't know if you want to talk to why people aren't using them, but I think the biggest thing is that they are actually the clamping force calculator is actually the single most visited page on our entire website. So more people hit that page every month than anywhere else, including our homepage. I think the biggest challenge with calculators is ensuring that we're delivering calculators that customers want and need. So we're always looking for feedback from customers on calculators that they can provide. If you're on our website, at the bottom of every page, we have a little button that says, "Was this page helpful?" And you can provide feedback there. And I review all of those.
And just to farther that, Colin, in terms of why, it's really just to make our users' life a little bit easier, right? We don't want to make you have to perform those calculations. It's just really to make it easy for the customers to use these tools.
So are you constantly adding new calculators or tweaking the existing ones then based on the feedback?
Absolutely. So as they come up, we review any request. We're trying to convert any of our existing calculations slowly to be dynamic calculators. And then also we're exploring new opportunities for these tools.
Okay.
So the one of the calculations that bedevils us, and I'm sure it bedevils many of our customers, has to do with manual toggle clamps. Right, manual toggle clamps have an arm. Right, the question is, I have a spindle of a certain length with a certain material of spindle and a certain arm length. How much retention force, how much clamping force is my toggle clamp exerting onto the workpiece? So we are working on building out that formula for a variety of different products, and then we'll deploy it within a calculator so that it's available to customers.
So,
but yeah, really anything we can do to make the designer's life easier and better, right? To improve that process of determining what item do I need to build my tool. That's something we're certainly focused on.
And what about more standard items? The question is, if you have that, isn't the configurator more complicated than just downloading the file that's needed?
Yeah, certainly. If you know exactly what you're looking for, if you say, I need a P326.2500 drill bushing, the walking through the configurator steps can be more complicated. However, if you say, gosh, the drill bushing I really need is a P346.2500, then I can tell you, well, based on what I know, that's a special. And you might say, I don't care if it's a special, I need it. And I'll say, okay, that's fine, but we don't have a CAD file for it. Right? You say, well, I can configure it, right? It follows the ANSI standards. Why don't you have a CAD file for it? Well, drill bushings are one of these monstrous animals for which there are millions of variants. So I think it becomes a trade-off for sure with the configurator. We believe that most of our customers and designers will go out, identify something that they need or they want to use, either now or in the future, and they'll download the CAD file. They'll then keep that CAD file within their system, within their shared drive, within their desktop, and they'll go back to that time after time. And so we see a fair number of people coming into configurators, getting what they want, right, and then dropping off for a little while.
So we're almost out of time here, but the products you discussed today, are they all available now in the market? And how can people purchase them, if so?
Sure. Josh, you want to speak to that?
Yeah, these products are all available right now. You can go to carlane.com. You can order them directly from our website. You can call customer service, reach out to one of our distributors, whatever works for the customer. Or if you need help selecting a product, you can always reach out to my team at engineering@carlane.com, and we can always help you select that. But yes, all products available in the webinar today are available for purchase.
And what about building custom parts or solutions? Who should people contact for that?
So if it's close to a standard, I would recommend going through RFQ@carlane.com. If it's a standard dimension change, maybe it's a grip length and it falls outside of the standard configurator ranges that we were speaking about, right? We can't have a solution that covers everything because some of these have to be investigated. But if it's a more complex item, I would recommend reaching out to engineering@carlane.com or giving us a call. Speaking to myself or one of my teammates, we'll be happy to assist you and discuss a solution for your part you're looking for.
All right. Well, thanks a lot, Josh, Callum. Anything else to add here?
We really appreciate everybody's time today and look forward to chatting again soon.
Well, thank you very much. As this webinar has shown, choosing the correct tools for a job can make a huge difference in process improvement. SME and SME Media can help you keep abreast of all the latest developments in workholding and other advanced manufacturing systems. Check out our podcast at advancedmanufacturingnow.com to listen to a wide variety of manufacturing professionals discuss the challenges, opportunities, and factors impacting manufacturing today. And always keep an eye out for breaking news and coverage of the latest technology and strategies for manufacturing at sme.org/latest-news. Thank you for joining us on this SME Media webinar. We hope you found it informative and that you'll join us for future webinars.